Awesome. Okay, that's cool. Okay. So, okay, so it's 4 p.m. or 10 a.m. Well, I guess it's 4 in the night. It's middle of the night in the US, but they can follow along. So today we're going to do a bit of Python. I'm going to show you yet another text editor with GF mode. So this is Atom, which has a GF mode. And let's see, I have prepared an extremely simple grammar, which is inspired by one of the exercises from the GF book, but even simpler. So what we're going to do is that we're going to create an English or other natural languages interface to run Unix commands. So I can do ls, or I can give some flags like list hidden files as well. So what I would like to do when we have this Python code that we'll write today, I want to do instead like Python list all files, for instance. But yeah, this foo.py doesn't exist yet, but that's the goal for today. So what I have prepared a small abstract syntax. I can actually add this.
On Zoom, I see on the screen.
Oh yeah, I'm not sharing my screen. Thank you. Yes, please let me know if I'm not sharing my screen. Forgot that. Okay. So here, I have made this extremely simple GF grammar for Unix commands, which only has ls. Only one command and only one flag. But the point of this is to do the Python stuff, so the grammar is extremely simple. Line. Pushing this. So now it's in the GFSS repo. Get a comment. Oh yeah, great. We have the stream link too. So the first we're going to make a concrete syntax. So this is such a simple grammar that it's going to be very quick. Concrete Unix C of Unix. We can. The C means just concrete. I can call it conc, so you don't think it's C language. So like this. A hack when you want to write really short grammars, if you want the lingets to be just a record of string, you don't even need to put the linget because the compiler does it for you. So the lingets are there, and then add flag fc is command.s ++ flag.s, and then ls else and all is. So it's not that, it's this instead. So now we can GF. Oh, where did I put it? The Unix conc Python app grammar. Need to be in the right grammar, right file. Now we can do GTL. So oh, also the right flag. So now this is completely overgenerating. We don't care about it. It's just we can do this. So if we parse ls, it's the command ls. And if we parse ls with the flag all, then we get this tree. And now, since I said we want to do a natural language interface, so we will instead GIF. This is such a simple thing. We're not using resource grammar, which I will present tomorrow how to use it. So what we're just going to do, I'm just going to say list all files. That's it. Unix eng parse and we linearize. So ls-a is list all files. And then we do ls, it's just list. So this is what we did right now. Let me add those changes too. I did concretes for Unix and this commit push, so you can follow along. So this is our grammar. This is our application grammar. And from now we're going to start writing Python. We've tested it works. Oh, actually, we technically didn't test that it works the other way around, but you know, like parse list all files. Yeah, it does work. We get it this way too. So now we need to start writing some Python. We're going to be using the Python bindings to the C runtime. There is some documentation on the GF homepage. So you go the GF main page and you click here, PGF library API, Haskell, C runtime. You click this, and then you click Python from here. So here is some documentation. And if you want to, I have a blog post that includes also the part of like how to install all this stuff. But if you're following along, actually, I would like to know if you have downloaded GF binary, I think you should have this. So you can test if you have it. Go to your Python shell, and then do import PGF. And if that works, then you have it. We have stuff like this. If you're having some problems, I can link this thing to you. So like the easiest way to install it is, it should be in PyPy, but we're aware that there are some problems with the newer Macs. So there are, yeah, if you have problems, like just, you know, let us know. Maybe we don't go into troubleshooting right now, but I will link this blog post here just in case. Here. Okay, so that was just to test that I have the Python bindings. Well, currently I have Python 2.7. It doesn't matter if you have Python 2 or 3. So now, what's PGF? PGF stands for Portable Grammar Format. So we need to compile this Unix grammar into PGF. So we do this. We can use GF, not just. So we did previously. We did GF. We used it as just as with GF shell. But now we can do. Oh, it was wrong. Just typed it wrong. So this is GF shell, but what we can do instead is to give the flag make. So we do this gf-make grammar slash all the concrete files. And this is giving us a PGF file. So now we have this in this directory. If we have a bigger project, maybe you have some opinions about module structure, but let's just put it here for now. And now we can start. Yeah, let's we can do a bit of demo. Let's open Python shell and just see what we can do with that grammar. So I open Python shell in the same directory as my PGF. And I import PGF, which is the library. Let's see what we have in scope. Let me know if the font size is too small or if something is not audible or I forget to share my screen. So I'm going to use this function or method read PGF. So pgf.read PGF. And then I give the name of the file. So unix.pgf. Okay, that's some kind of PGF object. Actually, I think I probably need to put it in some so gr equals this. So now I can do what's the type of gr? It's a PGF object. Oh. What can I do with it? Yeah, there's a bunch of stuff. By the way, all of this is also documented in here. So if you kind of miss this talk, you want to have a quicker overview, do it on your own time. Everything is here. What do you want to say? Help? Yeah, okay. So you can do this on your own computer and read it if you need help. Let's get functions of the GR. So GR functions. These are the functions. Categories. Yeah, so these are, if you're wondering what are these float into string, because if we look, what did we actually only wrote two categories here. So these are built-ins that they are part of every GF grammar ever. We haven't actually shown you how to use them. Yeah, that would actually be a good way to this, for instance, built-in string is that's like the way to prepare for any output, any input. So, but yeah, let's just do this. So what I want to parse and linearize. That's what we're interested in. So let's check out the documentation. Parsing. Okay, so in order to parse, I need a language. There is, if I do gr.languages, it's a map from language name to an object of class PGF conquer. So that's a dictionary in Python. So gr.languages, and that's a dict. Do I need to type Unix eng instead? Yes, I need to type Unix eng. So I'm going to do eng equals gr.languages Unix eng. And Unix. Oh no, it's called conc, not conquer. Okay, so now we have something more interesting we can do. eng.parse list all files. Oh, we get some iterator because that's how we do things in Python. So what can we do with the iterator? Let's put it in a variable, and then we can do i.next. Okay, so that's some kind of a pair. So let's bind these into something. So the first is the probability, and the second one's an expression. We can completely ignore the probability, so we can just do underscore exp equals. I.next. Oh, except that we kind of stopped. We are at the end of the iteration, so we need to just do this again. And now let's do this. Okay, now we have something in exp. Oh, we still need. We need to have some function that we need to do something more intelligent with it. So we can inquire its name. We can do all kinds of stuff. And we linearize it. Let's see what this is doing here. Oh, okay, we can just print it actually. Yeah, that's good. So we can just print exp. So this is, so far we have just duplicated what we can do in the GF shell. So let's see, this is like the difference is that we're doing this now inside Python, and we can, so this means that we're not bound to the GF shell. We can do this in any application. What else? Linearize. So we can linearize it in another. Oh, there's a comment. Is there a significance to the probability? I guess like the significance would come if we have like a very ambiguous grammar, and then we want to rank the trees when we parse something. Like we can the GF grammar can include, it's completely optional, probabilities file, and that can use to, when we have an ambiguous grammar, we parse something, we get 100 trees, we can rank them by the probabilities. But with this, it just doesn't matter at all, because this is like completely unambiguous. If Arne has something to add, just like feel free to step in. Okay, so we have the linearize, so let's do again dir.
And with me.
Yeah, same. Okay, so this is all the building blocks that we're going to need for our application. We have a way of, so we access the PGF grammar from Python to get a PGF object. We can use parse, like we can extract a concrete syntax as an object and the other concrete syntax as another object, and then we can parse in one and linearize in the other. So let's start writing some Python in this file. In a file. Oh yeah, this using Atom to show GF was not super interesting because I'm gonna write Python for the rest of the. So new file. I'm just gonna call it app.py. So import PGF like this. And then since we are going to talk about these external commands, so we have to do like this. Oh, this is actually exactly what this example is about. Okay. So, okay, this is like extremely simple. We're just gonna do it in this file. So I'm not gonna bother too much about the reading files stuff. Giving command line arguments, you can always tweak it, improve it on your own computer to make it more general. So I can do just this, gr pgf dot read, what was it again? Read pgf unix.pgf. Then I can say eng here. This. GF, move it into GF dot. To concrete syntaxes. And then, yeah, now we need to have this this Python program to read the command line. So it's so much easier to program in a language like Python, because whenever you have a problem, like I honestly don't know how to read stuff from Python command line because I hardly ever use Python, but I can trust that if I Google it, I get like a billion answers how to do it. Python read command line argument. Oh, 3 ways to read such parse. Oh, yeah, this is how I want to use it. Yeah. Not okay. sys.argv. Okay. Okay, like this. Great. Okay, yeah, so the first one is the name of the script, app.py, and the second one is the command that we're giving. So let's say if it's smaller than 2, we want to say that please give me a command to run. I want to serve you. This, so just say that is this. What does it do? I don't know how does it treat line. How does it treat if I have multi-lines? So if I do Python app.py hello. Oh, that was the typo again. So this is fine. Hello world. Okay, this is still. And now if I do this. Okay, but actually let's make it a bit more general. I'm gonna do like this. I'm gonna start it from that. And now if I say hello world, I get this. Exactly what I wanted. That's perfect. So the command is all of these. And so let's try to parse it in. Okay, if it's like, because if it's already Unix, then we just execute it. And if it's English, then we need to translate it. Is the command we read Unix or English? So let's try to parse it in both of these concretes. What did we do here? This. Try catch. So try catch in Python. Oh, it's called try except. Okay, that's cool. Like you Google something and then, or you even DuckDuckGo something, and you know you don't even need to search for the right thing. Let's see. AI. Try except exception. Okay. Let's see what kind of exception do we get. Python. Let's figure out. Try. Oh yeah, actually, let's do this. parse command. Oh yeah, now we actually need to, so this, when we get the command from this is the command as a list of strings, but we want to like concatenate it. So I think it's like this in Python. We run this now, so what are we getting? PGF parse error. Okay, that's great. So now we can put this in try catch, try except. Error. Then we try to, and we know it was actually already a Unix command. No?
Can you explain the if len sys dot here? So what would sys dot arg be written?
So the question was, can I explain this? So this part is just, that's one of the ways of reading Python command line arguments. So I just, this part reads the command line, see this bit. So I just copied some code from the internet. That's
Well, I'm thinking if I have ls, that's also a one word, and that's the two. So I'm thinking why would that? But no, my it's from there. Then
yeah. So like if I'm this is triggered if I just try to say Python py, please give me a command to run.
Okay, got it.
And then if I do anything else, it gets past it. But now, oh, I think I need to say pgf.parse error. So now, I get past this, but now since I try to parse something nonsensical, I'm getting unexpected token.
Okay.
And that happened on line 26. So the first one was in the try catch block. So actually, I'm kind of, oh yeah, it was trying to parse in English again. Unix.parse. So now we can see how this works. I can say exp print this was English, and then I do I need to do another try catch, I think. If someone who knows Python better can make this nicer. And another pgf.parse error. Print. Be more careful, don't give me nonsense input. Can I say la or le or something here?
La.
La. Okay. Yes, that was my. Yeah, that was my guess. Okay. And if it didn't, yeah. So. Oh yeah. Print was already Unix command. So now it's going there. But if I say list of files, yeah, this was English. It actually worked. And then if I say ls a, then it says this was already a Unix command. Okay, so yeah, okay, this is extremely simple. So that now we have actually already okay, we haven't done the the action part here yet. So let's translate between those two trees. Maybe we can simplify this a bit. So okay, so if it was English, maybe we don't actually need to print this out in the final. then what we do is that we want to translate it now, because if it was English, then we want to, like what we want to do, that we type this and it would actually give me the output of this. So we need to create the sub process now. Okay, first let's create the LSA, the translation. So we have the expression, and this is all assuming that it actually parses, because if it doesn't, then we just do something else. We use the Unix, so let's say linearization equals Unix dot linearize exp. So now this is what we read, and this is what we translated to. Actually, yeah, let's do this instead. It's a bit prettier to just return. Command list. Do this in only one place, so just make this a bit nicer. So yeah, this is what I typed. This is how it translates it to. And so yeah, the lin is correct here. So now let's see how we do this. Do the sub process. Sub process dot run. Okay, so that's actually pretty simple. Sub process dot run. Okay, what now this is not going to work if you just do lin, because what will happen? Oh, okay. Something else will happen too. Import sub process. Oh, this is something like Python 3 specific. Make sure you have at least this Python version. Oh, because it doesn't work on my computer for Python 3 because I have the Mac Big Sur busted. Okay. Oh, is that system? Okay, we can use that. Okay. Let's. Yeah. Okay. So let's. If everyone. Okay. Yeah. Let's change laptop, because like, there is a way to get this working on Big Sur, but I just kind of. It's. Yeah. Let's see. Does. Yeah. It's also working. Yeah, I'm gonna push this. So if you're following along, so I did the so I did the Python script. So this is like level 1 of doing Python stuff. Like, we're soon done with this example, and then I'm gonna show you a tiny bit more complex example. All of this code is in the repository. So let me stop share and we'll change which laptop is. Yeah. Yeah, it's pushed already. Can you share screen on Zoom? Yeah, you can present actually. That's good. Okay.
Yeah, so you can help yourself.
Okay. Oh, that's very generous. I wasn't hired here to be a Python programmer, so like I thought I'd. Okay. So you're seeing this. As you can see from, I'm trying to exit the Python shell by pressing Q. See the day 3. Oh yeah, I need to do. I need to now that I'm in a new on a new computer. I need to first do the gf -make grammar / Unix and grammar / Unix honk. Okay, now it's saying give me command to run, list all files. Oh, I think I need to do another thing. This was documented in the GF on the page, so .py. I need to do this maybe. Oh. Where? No such file or directory. Yes, so this is the error that I was expecting to get. Yes, it's if we remember what I'm reading documentation on my own computer, and I'm working on Regina's computer. So but we need to give a list of commands to the subprocess. So this should be rather easy fix. Just let's get back here and how do we split? Is it like, is there a comment like this? Split. Let's see if there is. Yeah, look. So now we can remove these printouts. We don't need to print it anymore. So we say list all files, and this is the output we get. Yeah, also don't need to print this.
You need to project on the screen.
Oh, sorry. So okay, I don't know where my Zoom disappeared. Sorry.
I just plug. Just plug this video, then you can see.
Yeah. Okay. I mean, okay. So we plugged this. Or so, okay. Yes. Problems. Oh no, I think I plugged the keyboard now. Sorry. Oh, I didn't. Oh, it thinks that the camera is keyboard. What? No, this is completely crazy. Okay, I mean, sorry. Let's just try to. Okay, sorry. Let's forget this. Let's try to get my setup working. This is not a good idea. My Zoom is just somewhere. Keep on top. Okay, we have recovered our setup. Sorry about that. Right, so where we were, we can run this command list of files, and it translates it into the Unix command. And now let's let's just complete this. So if we try to give it instead ls-a, here we're getting this unexpected token ls. So then we're going to say that, like, this was already a Unix command, talk to me in English, but we'll still do it. We'll still do the thing. So we can just do another subprocess .run, and what we can do, we can just do the original command as list, because that's what we could do. So apparently not. Oh, okay. Oh, I see what we need to do. We need to do the except pass error here instead. Wow, this is complicated. Does this work? Oh, this is Python 3 thing again. Yeah, okay. So it's for some reason doing it twice, but like, because yeah. Okay, so this wasn't like the most beautiful Python ever, but like, yeah, I think it got a bit complicated when we added this. It's already Unix command. Why are you doing this? So like, let's just put this somewhere. This is like an exercise to. This is an exercise, next level exercise. So let's just comment this out for a moment, and yeah, you need some homework. Like that's what you say when you're like a mathematician and you try to, your students ask you to prove a theorem, like, oh, this is trivial, this homework. So homework, make it work nice and respond to both English and Unix. So, homework for you. Is there an else branch in this Python try except thingy?
Yes.
Okay, that's great. So then I can just do else. So now I can do this. Oh yeah, I forgot.
Oh,
There was this part I
the
need.
except has got a colon there.
Oh.
Maybe that's it. And with the word except.
List of files.
Oh, yeah, correct.
Yeah, it works. Okay. So yeah, okay. So this part is it's even giving me, so now this command line doesn't even speak Unix anymore. It's just feeling insulted about this. So we try to parse it in English, and if we get a parse error, we reject it altogether. And if we successfully parse it in English, then we linearize it in the Unix grammar, and then we finally run the thing that we got. So this is, oh yeah, I think, can we, yeah, okay, so how about, Regina, can you make a fork, you can get your laptop back, make a fork of the repository and make a pull request with this. So we can take like a tiny break, and then I'll show you the level 2 of GF Python stuff. Thank you for thanks for giving me your laptop. That was very foolish of me to try to demonstrate Python and things not Python 3 not working for my computer. So thank you very much. Questions so far? Discord.
What's there in level 2?
In level 2, we have we're going to manipulate the GF trees.
Oh yeah.
Or is that would you advise against, or?
No, it's very good. Yeah. I think I will leave now. Thanks.
Sure. Thanks.
Lunchtime.
Oh yeah, it's lunch. Okay.
Yeah.
That's cool.
Thanks for it. Enjoy, everyone.
Are you still sharing your screen, Regina? Or okay.
I don't think so. I stopped sharing.
Okay, right. Okay.
Taking a break, right?
Yeah, let's take like a, what's the time? Let's take yeah, let's take a 5-minute break. We're probably not going to I think like I'm not gonna probably finish the example, but I'm gonna start an example and I'm gonna show you how to continue with it on your own. So 5-minute break. Okay. Hello again. Starting soon. Let's just. We have a pull request if I believe correctly. Regina. Open pull request. So here we have these changes we did in class. And I will merge the pull request, and now you can all get it if you just git pull this GFSS repo. Okay, now it's 7 to 5. So yeah, I'm not gonna, I realized that this simple thing took me almost an hour to talk, so I'm definitely not gonna talk another hour because it's soon lunchtime or whatever. But I'm just going to give you some pointers. So as things often are in the GF world, I pitch my blog because I've written like equally many words in my blog as in my thesis. So we have an example here that is, we have a full Jupyter notebook. I'm not gonna go through the whole example, but I'm gonna like look at it. So there is this repository, which I will link. In the chat. So before we go there, I'm gonna start with some commands that I didn't explain yet. If we go back here, I'm gonna open. I'll just start the Python shell again. This works in Python too, because I wrote that. Hopefully. Import PDF, no, lowercase, and we do this. Let's open the grammar again. So gr equals pgf dot read pgf remix of pgf. And again, we get English from gr dot languages. So now if we look at the the thing we still need to do is to get an expression. So we can do again, I is an iterator, and parse is files, and probability expression next. So now we have an expression which we can, this is the prerequisite thing I want to show you. So what can we do with an expression? We have this function called unpack. That's going to be interesting. So exp dot unpack. So what does it give us? It gives us a tuple where the first thing is the name of the constructor. So remember how does this expression look like? We apply this add flag function to all and ls. It takes it's one constructor and 2 arguments. And this unpack gives us the first argument as a string and the second argument as a list of PGF expression objects. So then we can do, I think, let's see, what do we get if we do apply fun? Oh, okay. Well, that's maybe not so useful. Let's just use unpack. Yeah, okay. Let's use unpack. That's kind of clear. So we can from this we can extract. We say f args equals f dot unpack, x plus unpack, and f is this add flag, and args is this. Oh, my typo. Args is this list. So then what we can do again, so args, we can do a dot unpack for a in args. So now this is the final form. We had the exp. Okay, whatever. When we unpacked the exp, first we got the add flag and this list. And then when we unpacked all these expressions in this list. Sorry, let me do it again so it's a bit less confusing. So f and args is x dot unpack. F is add flag. And then here, when we unpack all the args in args, we get these as strings, all and ls. And this corresponds to print exp add flag. So like, what's the difference here? We get structure. So if we just print this, like this is just a flat string. But when we first apply unpack for exp, we get this. We bind the string add flag to this variable f, and then we bind this list of expressions to this variable args. And then when we successively apply unpack to all of the expressions in args, we get also the strings all and ls. Wow, now it's exactly 5 o'clock. So like,
this is technically how is that done? You just have a foreign function interface to Haskell.
I mean, this is the question was if we have a foreign function interface to Haskell, and the answer is well, this is actually using C on the at the bottom, but like yeah, it's using C. So let's see if we can cause a seg fault. So let me try to. Let's see if we can do pgf.expr flag. Okay, let's try args and then try to eng linear. Oh, I accidentally created like a real thing. So let's do args plus args. Yeah, look. We got a seg fault. Or whatever we got. Now it's just an assertion failed. Yeah, okay. But Python quit unexpectedly. So like, okay. So this is the answer. Like this is what's it's using the C binding. So I tried to create an expression that was nonsensical, and then we get a C error. I mean, I deliberately I made nonsense, and I knew it was nonsense. But okay, so by using this calls to unpack, we can peel off the tree in a structured manner. And this is what I'm doing in this tutorial. So we can just have a quick look at this. I'll let you all have lunch, but just so this in this repository, I have the PGF there, like everything's ready, so you can just basically run this notebook, or you can examine it if you want to. this is the preliminaries that we went through on the class, so we can just skip to this part. Manipulating syntax trees. And I'm giving here some kind of linguistically inspired thing where we want to transform these sentences that have the same subject and object into reflexives. So that's the usage of the function. We apply it to some ICU, no change. But we apply it to ICMe, and then we get reflexive as an output. And then that's what we're going to do here. Like you can, if you're interested, you can just please clone this repository, inspect it yourself, do some modifications, see how that's done. But you're going to see the word unpack many times here. And the idea how we're doing it is that we start from some CL, and then we get its children from this unpack, and then we inspect the children, like if the VP starts with the construction complete For those of you who were in the morning lecture, this is like almost the same grammar. This is a mini grammar instead of the micro grammar that we did this morning. But like you should, these function names should be familiar to you if we were in the morning lecture, or if you've seen any of this before. So we're comparing the names, like, because remember the first argument we get from unpack is always a name, and the children is a list of expressions. So what we can do is that we compare the name of the function name, the constructor, and then we can do a certain action. If it's this, we do that. And if the subject is object, then we replace it with the refl VP. And that's the idea of this code. Like this was like a very high level introduction, but I suggest you look at it on your own time if you're interested. Yes, let's end this here for now. Any questions? If questions pop up when you do some Python stuff on your own, if you have any trouble with installation, please let us know on Discord, or make a bug report in the GF repository. Try random instructions on Stack Overflow. If nothing else, those of you who are up for it, let's hang out socially at 8 p.m. So in 3 hours from now. There is no fixed program. We're not going to stream it, so it's just free-form hangout. I'll be there. I hope to see you again. So, yeah.
Bye again.
Will not be the easy photo then to see.
Oh, I know. I was thinking like we can suggest a photo on Friday evening. Oh, right. Oh, sorry. Oh, yeah. We were talking about having a group photo. We could do it on Friday evening at 8 p.m. if that's so. I'm gonna advertise it for 2 more days so we get as many people as possible. We can stop streaming on YouTube. I think I don't have the rights to stop it. So thanks.